I'm sure you will have no trouble solving those equations. Okay, let's now do another problem. An 80 kilogram block and a 10 kilogram block are connected by a rope that passes over a frictionless peg. This can be referred to as a double inclined plane. It is inclined on the left and inclined on the right. So you have an 8 kilogram mass sitting on the left side of the inclined plane and a 10 kilogram mass sitting on the right side of the inclined plane. Okay, find the acceleration of the block and the tension in the rope. It is not different from the problem we just did. All we need to do is isolate each object and identify the forces acting on each of them. Alright, let's start with this 8 kilogram. Tell me, what do you think is the direction in which the system is going to move? This is a 10 kilogram at 50 degrees. This is an 8 kilogram at 40 degrees. So you would assume that the system moves like this. The 10 kilogram moves down and the 8 kilogram moves up. Well, that is a guideline to write our equations. Alright, first we will study the forces on the 8 kilogram. Can you do that on your own? What is the weight of the 8 kilogram? The weight of the 8 kilogram is its mass times g. 8 kilogram times 9.8 meter per second squared. That is 78.4 Newton, and that will be acting vertically down. Alright, what are the two components of that force? A component of that will be pulling the box down the plane. That will be mg sine theta, 78.4 sine 40 degrees. And the force pressing the block will be mg cos theta. That will be 78.4 cos 40 degrees. Alright. The force pulling the 8 kilogram down the plane is mg sine theta, which is 78.4 sine 40 degrees. That is 50.4 Newton. The force pulling the block down the plane is 50.4 Newton. Now the force pulling the 8 kilogram up the plane is the tension T on the string. So the tension T on the string. Do we need to worry about the forces that are at right angles? We don't need to worry about the force that is pressing the block onto the inclined plane, because that force will cancel with the normal force. They will be equal and opposite. So really we don't need to waste time on those two forces in such a problem. Alright, the force pressing on the surface and the normal force will cancel each other. Therefore, we will not worry about it. As a result, what is the net force on this 8 kilogram? The net force will be the tension T acting up the plane, 50.4 Newton acting down the plane. The net force will be T minus 50.4 Newton. And that net force must be equal to MA. So F net equal to MA. Let's write that equation. If this is the net force, T minus 50.4 equal to MA. M is 8 kilogram and A we need to find. So we have one equation which, when you write it in the standard form is the variables on the left, the constant number on the right. So that will be T minus 8A equal to 50.4. We have one equation using the 8 kilogram mass, and we do the same thing for the second mass. And I'm sure you can do that on your own. You may not be able to read what I have on the screen, so you can try that on your own. Let's now study the forces on the 10 kilogram mass. What is the weight of the 10 kilogram mass? The weight will be mg, 10 kilogram times 9.8 meter per second squared. That is 98 Newton acting vertically down. The weight is 98 Newton acting vertically down. Alright, what is the force that is pulling this 10 kilogram down the plane? That will be mg sine theta. That will be 98 sine 50 degrees, and that is 75.1 Newton. That is the force pulling the 10 kilogram down the plane, 75.1 Newton. Now, do we need to consider the forces at right angles? We don't, because they cancel each other. Now, what is the force acting on the 10 kilogram up the rope? The tension T is acting up the plane. There you are. Therefore, what is the net force on the 10 kilogram? Because the 10 kilogram is moving down the plane, the net force is 75.1 minus T. That is the net force on the 10 kilogram. And this net force must be equal to this mass multiplied by the acceleration. So you have a F net equal to MA, 75.1 minus T equal to 10A, and rewrite it in the standard form. We get 10A plus T equal to 75.1. And now you have two equations, T minus 8A equal to 50.4, T plus 10A equal to 75.1. Well, solving that equation is very simple. You don't even need the calculator. Now, look at the way I can do that right here. Subtract the top equation from the bottom equation. That means T minus T equal to 0. T disappears. 10A minus negative 8A will be 18A. And 18A is on the left side. Now 75.1 minus 50.4. So 18A equal to 75.1 minus 50.4, and you can find your A. Alright? This is what I did. T minus T equal to 0. 10A minus negative 8A is 18A equal to 75.1 minus 50.4. And solving that gives you T equal to 61.4 Newton and A equal to 1.4 meter per second squared. Now, these kind of problems are rather simple now, and you must be able to do these kind of problems. Okay, let's look at another problem. A box of mass 3.5 kilogram rests on a frictionless shelf. This is the